April 13th, 1970. More than 300,000 kilometers from Earth, Apollo 13 glides in silence toward the moon, a bright point in a void that does not forgive mistakes. From the window of the command module Odyssey, Commander Jim Lovell watches the blue planet shrinking in the distance. It floats over an ocean of absolute darkness. The hum of the fans and the metallic tapping of the controls are the only human sounds amid that eternal silence. Lovell slowly turns his seat, checks the pressure, temperature, and oxygen gauges. Everything seems normal. Beside him, the command module pilot, Jack Swigert, follows a routine checklist with the precision of a watchmaker. He stirs the oxygen tanks, verifies power to the fans, and marks each step with a neutral, disciplined voice. In the lunar module, connected by a metal tunnel, Fred Hayes checks the navigation and temperature systems. Houston's voice arrives with a slight delay, as if it were traveling through time rather than space. Odyssey, this is Houston. Proceed with the stirring of Tank 2. Copy, Houston, Swigert replies, activating the agitator of Tank 2. The click of the switch sounds insignificant, but it is the sound that divides history. In a corner of the tank, a damaged wire overheats, sparks, and ignites the liquid oxygen. The explosion is muffled, contained, yet devastating. The whole module shudders. The lights go out for an instant. Then the alarms begin to scream. Red and yellow lights ignite in a cascade, flickering over the panel like a swarm. Lovell grips his seat and looks at Swigert. What was that? I don't know, but it wasn't small. Hayes, from the lunar module, hears the noise like a distant thunderclap. Lovell? This is Hayes. Something hit the hull. Lovell checks the gauges. The voltage plummets. The oxygen pressure in Tank 2 reads 0. My God, he murmurs, the tank is dead. The three men move with automatic precision, but every action confirms what none of them wants to admit. Something essential has broken. Swigert adjusts switches. The meters keep falling. Hayes reports that the lunar module is getting debris against the outer hatch. Lovell floats to the window. He looks outside. Tiny silver particles spin slowly around the ship, lit by the distant sun. For a second, he thinks they are reflections, space dust, perhaps ice flaking off. Then he understands. Those aren't stars, he says softly. It's oxygen. We're losing oxygen. The air inside the Odyssey thickens with the metallic smell of overheated electrical systems. The fan's hum weakens. Lovell breathes slowly. He takes the microphone and speaks calmly, as if the words were part of a protocol no one has written. Houston, we have a problem. On the other end, the controller's voice sounds calm, almost routine. Say again, Apollo 13. I said we have a problem. An explosion, power loss, oxygen. Pressure dropping. Silence. Then only static. In Houston, the telemetry screens begin to fill with incoherent figures. Engineers exchange glances, unable to understand. No one has seen anything like this before. In space, Lovell shuts down the propulsion systems to prevent further damage. Swigert floats in the cabin, holding a flashlight that illuminates the tangle of dead switches and meters. Hayes tries to contact Houston from the lunar module, but the signal cuts out. In a matter of minutes, the ship that was supposed to take them to the moon becomes a dying hospital. The oxygen escapes. The electricity drains away. The temperature begins to fall. At 330,000 kilometers from home, three men hang suspended between the moon and nothingness. The most routine mission of the Apollo program has just turned into a race against the clock. And from that instant, a countdown begins that no one on Earth can stop. Between the years 1969 and 1970, the United States floated in a strange calm. The moon had already been conquered. The newspaper front pages had traded feats for fatigue. In the headlines, the name of the Apollo 13 mission barely took up a few discrete lines. For the public, the space race was over. What came now was pure routine. The men of the mission knew it. Apollo 13 was not an epic adventure, but a technical procedure. Collect samples, run experiments, check systems. In the eyes of the country, the glory had stayed with Armstrong and Aldrin. Now, it was about continuing a job. At the Kennedy Space Center, the three astronauts reviewed checklists with the serenity of those who have done this 1,000 times. Jim Lovell, the commander, was a veteran with a sailor's steadiness. He had orbited the moon on the Apollo 8 mission, had felt the loneliness of space, and knew how to tame fear. His voice conveyed authority without drama. Beside him, Jack Swigert, the command module pilot, embodied technical precision. He was methodical, quiet, with a prodigious memory for procedures. He had been added to the crew only days before launch, replacing Ken Mattingly after a possible exposure to measles. That last-minute substitution was seen as a minor detail, a logistical curiosity. The third was Fred Hayes, the lunar module pilot, serene, analytical, more engineer than pilot. Together they formed a team that symbolized NASA's efficiency, professionals without nerves, without egos, without room for error. On April 11, 1970, the Saturn V rocket rose over Cape Kennedy with a violence that split the air. The roar of the engines drowned out the applause. The column of fire lit the Atlantic, and in a matter of seconds, the spacecraft vanished into the clouds. In the control room, the engineers followed the data without visible emotion. Every number that appeared on the screens was correct. Everything worked as it should. Lovell looked out the window as Earth's curvature became evident. From up there, the planet was a blue and white mosaic, as beautiful as it was unreachable. Swigert, wearing his headset, murmured, "Houston, the insertion was perfect." A voice answered from Earth, "Copied 13, good work." It was a mechanical dialogue, almost cold, between men who no longer felt awe. In the offices in Houston, the tracking teams worked with the same calm. Lunar flights had become predictable, and that predictability had brought a silent enemy: absolute confidence. The procedures were so meticulous that no one imagined the possibility of a catastrophic error. The hardware had been tested again and again, the systems duplicated, the manuals reviewed to exhaustion. Apollo 13 was not supposed to offer surprises, and precisely because of that, no one expected them. As the ship moved away from Earth's glow and ventured into the translucent darkness of deep space, the distance was measured in kilometers and in confidence. Houston watched on screens full of numbers, the astronauts, in the absolute silence of a universe that already seemed domesticated. Space, however, never stops collecting its debt, and routine, when it becomes certainty, is the antechamber of disaster. Months before launch, in a nondescript room at the Kennedy Space Center, a group of technicians went over the Odyssey's component list. Among them was oxygen tank number 2, a steel sphere a little more than 1 meter in diameter that was to feed the command module's electrical and life support systems. It was, essentially, the ship's invisible heart. During a routine test at the assembly base, the tank showed an anomalous pressure reading. It was not a burst or a leak, just a figure out of range. The on-duty engineer noted the deviation in the report and, following procedure, recommended replacing the unit. But the Apollo program's schedule was not flexible. Every day of delay meant millions of dollars lost and weeks of readjustment in a logistical chain that moved more than 300,000 people. In a technical meeting, a supervisor asked whether the repair could be done without removing the tank. "We can recalibrate it," one of the engineers replied. "The system will hold." It was a common phrase at NASA in that era, a blend of precise calculation and confidence acquired after years of success. No one wanted to be the one to stop the launch over a doubtful reading. The tank was repaired, a valve was replaced, the sensor adjusted, the compliance document signed. The anomaly was filed away in one more folder among thousands of daily reports. No one mentioned it again. During the last night of tests, in March of 1970, a technician detected that the tank was taking longer than normal to empty. To speed up the process, it was decided to heat the oxygen with an electrical resistance. What no one noticed was that, in doing so, the tank's internal temperature exceeded safety limits. The insulating coating of the electrical wires, made of Teflon, melted silently. From that moment, the tank was damaged. Outwardly, it was intact. Pressure remained stable, the valves responded, the readings were normal. But inside, the wires that ran through it were carbonized, ready to produce the short circuit that months later would puncture its wall. 3 days before launch, a young engineer reviewed the maintenance log. He found the overheating report and mentioned it to his superior. "Should we replace it?" he asked. The boss looked over the document, leafed through it, and finally answered, "If there were danger, it would have failed in the tests. The tank is clean." That conversation ended in 30 seconds. On April 11th, when the Saturn V rocket roared above the launch platform, no one thought about that tank. It was hidden under layers of steel, protected by a structure that seemed invulnerable. But in space, there is no room for small compromises. 3 days later, when Swigert activated the stirring system, the carbonized wire of tank number 2 made contact with the metal structure. The liquid oxygen, under enormous pressure, became a perfect bomb. A microscopic failure on Earth turned into a cataclysm 300,000 kilometers away. And in an organization accustomed to controlling every variable, that small error would be the line separating a mission from a tragedy. April 13th, 1970. Houston time, 9:07. In the Odyssey, the atmosphere was calm. The 3 men were at the routine of their 3rd night of flight, going over checklists they had repeated hundreds of times in simulators. The module rotated slowly on its axis, allowing the sun to warm the fuselage evenly while Earth fell behind and the moon grew before them. "Time to stir the tanks," Swigert said in a neutral tone. It was a minor task. It was enough to flip a switch to mix the liquid oxygen and keep it from freezing. Lovell nodded without lifting his gaze from the navigation indicators. The switch clicked. For a second, nothing happened. Then, a small blue flash ran through the inside of tank number 2. The electric arc pierced the damaged insulation and ignited the liquid oxygen. Inside the metal sphere, the pressure spiked. In milliseconds, an invisible flame pierced the tank wall. The explosion was muffled, damped by the vacuum of space, but the jolt resounded through the fuselage. The Odyssey vibrated like a wounded living body. The lights went out and came back on. One alarm after another began to sound. First the electrical system, then the tank pressures, then the fuel supply. "What the hell was that?" Hayes shouted from the lunar module. "I don't know," Lovell answered, looking at the panels. "We have a massive power failure." Swigert floated toward the main board, adjusting switches in search of a response. "Checking voltage. It's falling fast." "Oxygen pressure," Lovell said, his voice tense. "0." For a few seconds, they all stayed silent, as if sound itself might worsen the damage. Then Lovell pushed himself to one of the windows and saw something that chilled his blood. Hundreds of white particles streaming from the ship and floating into darkness. "Those aren't stars," he murmured. On Earth, the telemetry signal turned to chaos. In Houston's control center, monitors showed impossible data. Pressure at 0, erratic voltages, multiple alarms. Engineers exchanged bewildered looks. No one understood what they were seeing. "We have voltage loss on the CSM," reported the electrical controller, Cy Liebergott. Gene Krantz leaned over the console. "Say that again." "The ship is losing power and oxygen." Voices rose in the room. No one had a precedent for a failure like this. For a few moments, all the systems seemed to die at the same time. In space, the 3 men still did not know what had exploded. Swigert and Hayes began checking backup systems while Lovell kept calm with almost military precision. "Odyssey to Houston, we have a problem," he said, pronouncing the words with a serenity he did not feel. The silence on the line lasted only a second, but it felt eternal. From Texas, the voice of Jack Loosma, the capsule communicator, sounded confused. "Copy 13. Can you repeat?" Lovell pressed the transmitter. "Houston, we had an explosion. Oxygen pressure is dropping rapidly." In the control center, the air grew dense. Technicians began frantic calculations. No simulator, no training session had contemplated this scenario. In a matter of minutes, the Odyssey had gone from a flawless spacecraft to a wounded shell. An entire oxygen tank had vanished, taking with it part of the electrical power source and the life support system. At 330,000 kilometers from home, the 3 men watched the flickering indicators and understood the essential thing. They were alive, yes, but their ship was not. In Houston, among screens full of incoherent data, someone said softly, One of the tanks no longer exists. In the Mission Control Center in Houston, the clock read 9:08. The telemetry screens began to flicker with impossible numbers, simultaneous pressure drop, power loss, contradictory signals. Engineers leaned over consoles trying to order the digital chaos unfolding in front of them. Each monitor told a different story, and none made sense. Amid that confusion, Flight Director Gene Kranz raised his voice above the murmur. Quiet. No one speaks without data. The noise stopped at once. All that remained was the electric hum of the air conditioning and the nervous tapping of keyboards. Kranz, standing with his white vest perfectly buttoned, surveyed the monitors. His face showed no fear, but in his eyes there was something no one in that room had ever seen in him: doubt. Controllers began to list problems. Power loss in fuel cell 1. Oxygen. Pressure 0 in tank 2. Drop in fuel supply. Erratic telemetry. It was as if every system on the Odyssey had decided to die at the same time. Kranz took the microphone. "Odyssey, this is Houston. Confirm the failure." The answer arrived a few seconds later, distorted by static. "Houston, it looks like we've had an explosion. Oxygen pressure is dropping." Lovell's tone was calm, almost cold. But the engineers understood what those words meant. The room filled with tense silence. Some looked at each other, others took hurried notes. On the monitors, the readings fluctuated without pattern. No one knew whether the module had been struck by a meteorite, whether an electrical system had failed, or whether the ship was slowly disintegrating. "We need to isolate the problem," Kranz said. The head of electrical systems answered without lifting his eyes from his console. "It could be a short circuit, but it wouldn't explain the pressure loss." Kranz frowned. "Then we don't have one failure, we have several." In space, the astronauts tried to remain calm. Swigert reported the voltage drop, Hayes checked the lunar module's indicators, and Lovell did mental consumption calculations. They knew they were losing oxygen at an alarming rate. If the leak did not stop, within hours there would be no air or electricity. Lovell opened the main channel. "Houston, we are seeing gas leaks into space. Repeat, visible leaks." Kranz clenched his fists. "Tell the astronauts to stay calm." The capsule communicator, Jack Luzma, repeated the message with a serene voice, as if talking to a man trapped in the void required pretending normality. Engineers tried to reassemble the data on improvised whiteboards. Some drew diagrams of electrical systems, others added pressures and consumptions with trembling pencils. Every number seemed to lead to a new question. At that moment, the knowledge accumulated over years of tests and simulations ceased to help. Nothing in the manuals explained how to keep alive a ship collapsing from within. The Odyssey had been designed to resist the cold of space, the vibrations of launch, and the heat of re-entry. But not this. Not an invisible enemy born from its own interior. The failure of its mechanical heart. In seconds, everything learned had become useless. And in Houston, while the glow of the screens reflected on exhausted faces, Gene Kranz understood that the mission no longer consisted of going to the moon. From that moment on, it was about bringing them back alive. In Houston's control center, the apparent calm was only a facade. Behind every console, engineers wrote feverishly on sheets that piled up as if they wanted to trap time before it ran out. The lights of the great mural panel, which showed Apollo 13's trajectory toward the moon, seemed colder than ever. The white line representing the orbit kept advancing, but the mission had stopped in everyone's soul. Esuau, Liebergott, responsible for the electrical and life support system, was the man looking at the most terrible numbers. The 3 oxygen tanks were linked to the fuel cells that produced the ship's electricity. One was gone, the second was losing pressure, the third barely held. Each pressure drop meant less power, less air, less time. Kranz approached his station. "Sigh, I need a diagnosis." Liebergott did not lift his eyes. "We have total loss in Tank 2. Tank 1 is dropping. Fuel cell voltage is below the limit." "What do we have left?" Liebergott hesitated a second before saying it. "Nothing that lasts more than 2 hours." The phrase fell like a blow. Kranz clenched his jaw. 2 hours. That was not enough either to reach the moon or to return. Meanwhile, 330,000 kilometers away, Lovell looked at the gauges with the forced serenity of a captain who knows panic is useless. Houston, confirming. Oxygen falling. Cell 2 dead. Cell 3, unstable. Kranz's voice arrived, broken by interference. Roger, 13. We're evaluating options. Stay calm. Lovell shut off part of the automatic systems to save power. The Odyssey's lights dimmed, leaving the cabin in a blue dusk. Swigert checked emergency switches. Hayes held a flashlight as he tried to calculate the remaining oxygen consumption. None of them said what they all thought, that they were running out of life. In Houston, Kranz gathered the team leaders in a corner of the control room. "Don't tell me what's broken," he said. "Tell me what still works." Silence fell immediately. Finally, an engineer answered, "The lunar module." Kranz nodded slowly. "Then we'll use that." It was not a new idea. In theory, the lunar module could support 2 men for 2 days, but now it had to serve 3, for at least 4. The calculations seemed impossible, but there was no other option. Aboard, Lovell understood the same thing without being told. He looked at Hayes. "Get ready to power up Aquarius. If the Odyssey keeps falling, we'll abandon it." Hayes nodded without speaking. The decision was as logical as it was terrifying. To save themselves, they would have to take refuge in a module designed to walk on the moon, not to return to Earth. In Houston, Kranz gave the order. "Shut down the command module. Transfer life support to the lunar module." "Shut down the Odyssey?" an engineer asked, incredulous. "If we disconnect it, we might not be able to start it again." Kranz looked at him coolly. "If we don't, there won't be anyone to start it." From that instant, the mission officially changed purpose. The moon was no longer the destination. The new objective was survival. While the control center reorganized shifts and protocols, the mural screen continued to show Apollo 13's white trajectory curving slowly toward the moon. No digital line could reflect the real weight of what was happening. 3 men, lost in the void, 1,000,000 technological parts failing, and an entire agency trying to rewrite physics against the clock. The command module's power system was dying, the oxygen was running out, and all that remained was time, counted not in hours, but in breaths. The air inside the Odyssey began to turn humid and thick, a cruel reminder that the oxygen was escaping uncontrollably. The cabin lights flickered with a weak, almost dying glow. Lovell looked at the indicators once more. The figures left no room for doubt. The command module was dying. "We're moving into Aquarius," he finally said, his voice dry and firm. It was not an impetuous order, it was a surgical decision. The lunar module, known as Aquarius, hung from the Odyssey like an auxiliary capsule, meant to house 2 men for little more than 48 hours. Its original purpose was to descend to the lunar surface, not to keep 3 people alive in the void. But at that moment, it became their only hope. Hayes floated to the hatch and began the manual power-up sequence. The sound of the switches echoed in the empty cabin. The air in the lunar module was colder, thinner. Condensation covered the walls and the smell of metal was stronger. "Welcome home," Hayes joked in a threat of a voice. Swigert pushed his floating body through the tunnel connecting the 2 modules, carrying the checklists and the navigation equipment. Lovell was the last to leave the Odyssey. Before closing the hatch, he looked around. The main cabin was in semi-darkness, covered in blue reflections. It was the heart of the ship, the symbol of technological conquest, and now it was left behind, empty and powerless. "Shut it all down," Lovell said. From Houston, the order came at the same time, confirming the inevitable. Gene Kranz, standing before his console, spoke in his most controlled tone. "Odyssey, this is Houston. Anything not vital dies now." The words floated in the air like a sentence. One by one, the Odyssey systems were disconnected. Environmental control, gyros, heating, navigation. Each shutdown was a calculated sacrifice. The ship sank into darkness, lit only by the glow of the lunar module's panel. Aquarius was tiny, almost claustrophobic. There was no room to move or rest. The 3 men took turns staying awake, working with their feet tucked among cables and manuals floating around them. The cold took hold inside quickly. The temperature fell below 5 degrees. The vapor of their breath formed clouds that lingered in the air. From Earth, engineers adjusted energy calculations with obsessive precision. Every amp mattered. Every watt had to be measured. If they consumed more than necessary, they would freeze or suffocate before getting home. If they shut down too much, they could lose control of the ship. There was no margin for error. The Odyssey was left drifting, turned into a dark shell. Aquarius became its brain and lungs. Through the small module filtered the echo of space, an absolute silence that made them forget that, in reality, they were still moving at more than 5,000 kilometers per hour. Lovell, seated by Aquarius's circular window, looked outside. Planet Earth was a blue and white point suspended in blackness, as beautiful as it was unreachable. "Houston," he said softly, "Aquarius is operational." From Texas, a voice answered, "Roger 13, welcome to the lifeboat." From that moment, Apollo 13 ceased to be a scientific mission. It was no longer an expedition to the moon, but a desperate attempt to return from the void. Space, which had been a stage of glory and exploration, revealed itself for what it always was, a place that does not forgive. And Aquarius, an improvised emergency capsule suspended between life and nothingness, became the only frontier between humanity and eternal silence. In Building 30 at the Johnson Space Center, the dawn of April 14th arrived without anyone noticing. Flight control had gone more than 12 hours without rest. The white light of the neon lamps and the constant glow of the screens replaced the sun. At that moment, NASA's Nerve Center no longer looked like a temple of progress, but an improvised refuge against disaster. Flight teams organized in 12-hour shifts. Some slept in the hallways, others in cafeteria chairs, and a few had been awake since the previous night. No one spoke of heroes. No one thought about history. All that was left was work. In the front row of consoles, Gene Kranz held a cup of coffee that no longer had flavor. His white vest, a symbol of authority in normal times, was wrinkled, dirty, stained with sweat and ink. In front of him, the screens showed a tangle of numbers: oxygen consumption, voltages, temperatures, carbon dioxide pressure. Every number was a line between life and death. The atmosphere in the room was one of absolute concentration. Every engineer had an assigned role, but the roles no longer served. The protocols written over years did not contemplate a situation like this. The procedures were useless against a dying ship slowly turning between Earth and the moon. A young engineer from the electrical team looked up from his console and murmured, "We don't have a manual for this." Kranz heard him and nodded without irony. "Then we'll have to write it." From that moment, NASA stopped being an army of protocols and became controlled improvisation. Engineers filled whiteboards with handwritten formulas, drew schematics on napkins and on the backs of flight reports. The walls filled with diagrams, calculations, and power lines traced with marker. Each console represented a life, each error a death. In the adjoining room, support teams began to redesign the mission from scratch. The propulsion specialists calculated how to use the lunar module to adjust trajectory. The life support specialists tried to estimate how much air was left. Electrical engineers did mental equations on power consumption, trying to keep essential systems on without draining the batteries. The conversations were dry, without drama, yet charged with urgency. How much power do we have? 120 ampere hours in total. And how much do we need for re-entry? At least 90. Then we can only spend 30 in 4 days. Kranz listened and nodded. "All right, find how to do it." Engineers knew the astronauts up there had no time for debate. Every second that passed, the cold increased, the water reserves shrank, the carbon dioxide accumulated. In the side offices, other teams built scale models of Apollo 13, assembling exact replicas of the electrical and life support systems. Every change made in Houston had to be tested on that earthly copy before being transmitted to space. It was like playing chess with death across 500,000 kilometers. The corridors of the control center filled with papers and coffee cups. Faces were gray, eyes red. Even so, no one left their post. Outside, the world still failed to grasp the magnitude of what was happening. In the day's newspapers, headlines still spoke of minor problems in the mission, No one knew that NASA, the most methodical organization on the planet, was learning to improvise on the fly. For the first time in its history, space was not a technical challenge, but a human one, and survival depended not on the manuals, but on the capacity to think the impossible. The silence inside Aquarius was almost physical, a presence that clung to the skin. The fans barely hummed, weak, forcing air that felt heavier by the hour. The module's metal was so cold it seemed alive, exhaling its own breath. The lights, dimmed to save power, cast a bluish glow on the exhausted faces of the three men. The temperature had dropped below 3 degrees Celsius. The vapor of the astronauts' breath formed small clouds that floated before their faces and faded slowly. Their hands were numb, the water in their canteens was icy. At times, the sound of condensation drops hitting the panels broke the silence, a constant reminder of the moisture building on the walls. Jim Lovell tried to maintain mental discipline. Every hour he noted oxygen, pressure, and temperature readings, though he knew the figures were less and less useful. His voice, when he spoke with Houston, sounded serene, but his body shivered. In each transmission, calm was his shield. Fred Hayes coughed frequently. He had gone days without sleeping more than scattered minutes. His suit smelled of metal and plastic, his skin of damp and weariness. The food, rationed since the explosion, consisted of minimal portions of pasta and freeze-dried fruit they could no longer heat. The water, restricted to less than half a liter per day, was divided among the three. Thirst became a constant, a stab that accompanied each breath. Jack Swigert, quieter than ever, watched Aquarius's systems with fingers stiff from the cold. He tried not to think of the obvious. That module had not been designed to keep them alive for so long. His eyes followed the carbon dioxide gauge, a needle that climbed millimeter by millimeter as if it were measuring their fate. Within a few hours, the CO2 readings began to spike. The lunar module used lithium hydroxide canisters to absorb exhaled carbon dioxide, but Aquarius's canisters were smaller than Odyssey's. They were designed for 2 men over 2 days. Now, 3 men were breathing the same air, and the needle showed it would soon be toxic. "Houston," Lovell said over the intercom, "CO2 readings are rising. The canisters are saturating." Kranz's voice answered from Texas, deep, tired. "Roger 13. We're reviewing options. Stay calm. Stay calm." It was an impossible order in a ship where the air thickened, the cold bit, and the body began to ache from exhaustion. The walls oozed water. Ice formed on the control panels. Every exhalation left a shiny film of moisture on the switches. Hayes rubbed his hands, his knuckles red. "If this keeps up, Aquarius will be a freezer before we get home," Lovell answered without raising his voice. "Then the freezer had better breathe." From Houston, engineers made frantic calculations. The square canisters from the command module, still in the Odyssey, did not fit the round openings in Aquarius. The systems were incompatible, as if the ship itself refused to be saved. If they did not find a way to adapt them, carbon dioxide would kill the astronauts long before they ran out of oxygen. By then, every breath had a measurable cost. Every word raised the CO2. Every minute stole air. Lovell shut the radio off for a few moments to save battery. Silence returned, accompanied by the distant sound of their own heartbeats. He looked at his crew and thought that space, for the first time, was not a place of discovery, but a tangible enemy, invisible, cold, and patient. In Aquarius, the men were still breathing, but the air was on a countdown. In a few hours, the air would be poison. In one of the smaller rooms at the Johnson Space Center, far from the bustle of the main control, Gene Kranz gathered the men who could still change Apollo 13's fate. It was a group of life support engineers, electrical technicians, and environmental systems designers. The air smelled of stale coffee, sweat, and graphite. No one spoke loudly. All knew they stood at the border between life and death. Kranz placed both hands on the table. "CO2 is rising," he said. "The lunar module's canisters will saturate in a few hours. If you don't find a solution, those men will suffocate." He paused. "And we don't have compatible spare parts." The head of life support, Ed Smiley, a calm-looking engineer with nervous hands, looked up. "Then we'll have to make one." "With what?" one of the technicians asked. Smiley turned toward the central table. "On it, Assistants began to dump a box with all the objects the astronauts had on board: plastic bags, air hoses, manual covers, clips, cardboard tubes, duct tape, cable ties, and pieces of foam. The engineer looked at them in silence for a few seconds. "From this," he finally said, "we have to make an adapter that saves 3 lives." There were no further instructions. The men began to move. One cut, another measured, another bent the tubes. Hands trembled, not from fear, but from exhaustion. Hours passed and the worksheets piled up on the table. Clocks marked the time the astronauts could not afford to lose. Smiley sketched on a crumpled piece of paper. In the drawing, a square canister from the command module had to fit into the round intake of the lunar module through an improvised connection. They called it, with nervous humor, the square peg in the round hole. Materials transformed under the pressure of time. A manual cover became a gasket, a plastic bag, an air duct, a piece of cardboard, a ceiling base. Each piece was an act of faith. In another room, a communications engineer kept calculating the remaining time. CO2 is already at 15 millimeters of mercury. If it reaches 20, dizziness begins. Krantz listened without taking his eyes off the clock. Then make it work before 20. For 7 hours, the engineers worked without rest. There were no breaks, no lunches, no calls. The room looked like an improvised workshop, covered in plastic scraps and tape. The men passed parts without speaking, and the only sound was the snip of scissors and the hum of fans. At 3 in the morning, Smiley raised his head. In front of him was a rudimentary model, a tube assembled with a manual cover, a hose sealed with tape, a structure held by gray tape that looked like it came from a grade school class. But if it worked, it would turn Aquarius's poisonous air into breathable air. Krantz entered the room and looked at the device. "Is that it?" Smiley nodded. "It's ugly, but it breathes." A technician connected the model to the simulation system. The readings dropped. The CO2 went down. Krantz exhaled slowly. "Good. Now teach them how to build it up there." The mission had shifted from engineering to craftsmanship. NASA, the most methodical organization in the world, was being forced to improvise. While engineers translated their creation into a set of instructions, someone wrote on a whiteboard the phrase that would be repeated for decades in the agency's hallways: "Failure is not an option." And at that moment, that conviction was the only thing keeping Apollo 13 alive: duct tape, plastic, and hope. In Houston's control center, the voices sounded hoarse and worn, yet firm. At a side console, a life support engineer held a microphone with hands shaking from fatigue. Beside him, an exact model of the improvised device rested on the table: a structure made of duct tape, plastic bags, a hose, and a cardboard cover. It looked like a school toy, but at that moment it was the most important object on the planet. "Apollo 13, this is Houston," the life support engineer began. "We're going to try something new. Prepare the duct tape, the urine collection bags, a ventilation hose, and a manual cover. Repeat: tape, bags, hose, and cover." In Aquarius, Lovell turned to Hayes and Swigert. The three looked at each other in silence, sharing the same sense of disbelief. They were frozen, exhausted, and mentally numb, yet they moved. There was nothing else to do. Swigert floated to the storage compartment, pulling out the objects one by one. The plastic bags billowed in the cold air, the tape peeled off with a sound that seemed to boom in the quiet cabin. Hayes held the flashlight while Lovell listened to the broken voice coming from Earth. "First, cut the manual cover in half." Swigert obeyed, his fingers stiff from the cold. "Now insert the hose in the corner and secure it with tape." "Copy, Houston," Lovell replied. For nearly an hour, the three men worked, following the instructions word for word. The module's light was dim, barely enough to make out the tools. Every movement took twice the effort. The air felt heavier, thicker. The CO2 kept rising and every breath burned their throats. Hayes held the bag while Swigert wrapped the joint with tape. The tape, rigid from the cold, did not stick well. Lovell, in a low but firm voice, set the rhythm. "Keep going. Don't think. Just keep going." From Houston, the engineers listened in silence. No one breathed in the control room. Only the monotonous voice of the technician reading steps and the crackle of paper and plastic on the other end of the line could be heard. After nearly 2 hours, the improvised adapter was ready, a collection of incongruous pieces tied together with gray tape and faith. Lovell looked at it without a word. If it worked, they would live. If not, they would die breathing their own air. "Houston, we're ready to test it," he finally said. "Copy 13. Connect the adapter to the ventilation system and turn the main valve." Lovell placed the end of the tube in the round intake of Aquarius's system. For an instant, nothing happened. The air remained dense, the fan's sound unchanged. Then the hum shifted tone. The CO2 gauge moved slowly downward. "Houston," Swigert said, hardly believing it, "readings are dropping." At the life support console, an engineer smiled for the first time in days. "Confirmed. Carbon dioxide level is coming down." Lovell leaned back against the metal wall, exhaling a cloud of vapor. For the first time since the explosion, he breathed without pain. Hayes closed his eyes. Swigert rested his head against the panel. No one spoke for a few seconds. There was no need. In Houston, Krantz watched the figures stabilize on the screens and let go of the breath he had been holding since dawn. "We did it," he said quietly, without raising his arms, without celebrating, just with a tired smile. For the first time in 3 days, the men of Apollo 13 breathed clean air. A strip of duct tape, a hose, and a plastic bag had done what billions in technology could not: give them back their lives. The air inside Aquarius was a sigh. After days of exhaustion, hunger, and cold, the 3 men were spent. Their pale faces, cracked lips, and sunken eyes spoke of a fatigue deeper than physical tiredness, the fatigue of time, of knowing that every minute might be the last. CO2 no longer threatened them, but now they had a new enemy: the return. Apollo 13's trajectory carried them beyond the moon on a curve that would bring them back to Earth by pure gravity. However, the entry angle was not correct. If they came in too steep, the ship would burn up in seconds on contact with the atmosphere. If too shallow, they would skip like a stone on water and vanish into space. There was no margin for error. The navigation computer was off to save power. Automatic systems slept. Everything would have to be done by hand, the old-fashioned way, as in the first test flights, when pilots still trusted their instincts more than the machines. In Houston, engineers had calculated the exact impulse: 14 seconds of burn on the lunar module's main engine. Not one more, not one less. Gene Kranz gave the order. "Lovell, you're going to have to do it manually. Use the sun as a reference and align with Earth's horizon." The reply came in a hoarse voice. "Copy, Houston. We'll eyeball the alignment." Lovell settled into Aquarius's seat. In front of him, the window showed a bright circle, the sun fixed in a black ocean. At the lower edge, barely visible, a blue line, Earth's rim. That was his only guide. No radar, no gyros, no computer. Only the geometry of sight and faith in his reflexes. "Jack, time exactly 14 seconds, Lovell said. "Copy," Swigert answered, tense, holding his wristwatch before his frozen face. "Fred, watch the thrust. If we drift, correct." "Roger." For a few seconds, nothing was heard but the creak of metal under thermal stress. Then, Lovell placed his hand on the engine switch. "Houston, initiating the maneuver." Ignition thundered like a heartbeat in the dark. Aquarius shook. The floating tools struck the walls and the 3 men clung to the controls. Lovell kept his eyes fixed on the sun, using Earth as the horizon. 5 seconds, Swigert said. 10, 11, 12, 13, 14. Lovell cut the engine. Silence returned. Only the faint sound of the fans and their own breathing filled the module. Hayes watched the improvised instruments. The trajectory indicator's needle wavered for an instant, and then stabilized. "Houston, the maneuver is complete." In Texas, engineers checked the figures. The angle was perfect. "Copy 13, you are on re-entry course." Lovell looked out the window. Earth was now larger, nearer, a blue disk growing slowly. "Well, boys," he said in a hoarse yet steady voice, "homeward bound." For a few seconds, no one spoke. In that silence, 4 days of fear, hope, and calculation were concentrated. The maneuver had worked. But Earth was still far off, and death still had many chances to catch them. All that remained was to wait for the batteries to hold, wait for the parachutes to deploy, wait for the ship, damaged and frozen, to withstand one last battle against gravity. Lovell closed his eyes for a moment. In the reflection of the glass, the sun's light mixed with the distant blue of the planet. And for the first time in days, he thought of his family, of the promise he had made before departing. "I'll be back." Now, at last, he had a real chance to keep it. On April 17, 1970, after more than 87 continuous hours of tension, Apollo 13 approached Earth. Inside the lunar module, the air was dense and heavy. The walls were covered in frost, the suits damp and stiff. None of the three men had slept more than a few hours in total. Fatigue was no longer physical, but something deeper, a kind of exhaustion living between mind and soul. Lovell floated to the window. Earth filled the horizon, a blue giant wrapped in white clouds, so close and yet still so unreachable. In a matter of minutes, they would have to trust their lives to a damaged metal shell and to their home planet's atmosphere. The moment had come. Aquarius, which had been their refuge, had to be jettisoned. The sequence was irreversible. Lovell looked at the control panel, then at his crewmates. "Time to say goodbye." Hayes nodded in silence. Swigert checked the checklist one last time. Lovell pressed the switch. A sharp jolt shook the structure. Through the window, the lunar module began to drift away slowly, spinning on itself as the sun bathed it in golden light. Lovell watched it until it disappeared into darkness. "Goodbye, Aquarius. Thank you." For 4 days, that fragile capsule had been their home, their only protection against the void. Now they left it to die in space, turned into silent scrap. The Odyssey, reactivated for re-entry, had power again, but it was only a shadow of what it had been. The essential systems worked, the rest had been sacrificed. The three men strapped into their seats, watching the indicators flicker. Lovell took the controls. In Houston, Gene Kranz stood before his console. He did not speak. He did not move. He only watched the screens. Around him, dozens of engineers remained motionless, headsets on, hands clasped, eyes fixed on the clock. Apollo 13 hit the atmosphere at more than 39,000 kilometers per hour. Friction turned the air into fire. From the surface, the module was barely a shooting star crossing the Pacific. Inside, the heat rose at once. Vibrations shook the ship. The metal groaned like a living being. Communications cut out. The ionized air formed a shield that blocked all signal. In Houston, the line went mute. The stopwatch began to count. 1 minute, 2, 3, 4. No one breathed. Kranz pressed his fists against the edge of his console. The silence was absolute, unbearable. Hundreds of people in that room and across the world waited for a sound, a word, a proof of life. The clock hit 4 minutes and 23 seconds. And then, a crackle, static, interference, began a voice. "Houston, this is Apollo 13. We're home." The control room erupted. Men rose from their seats, applauded, shouted, cried. Some embraced. Others simply kept looking at the screens with wet eyes. The noise was deafening, but it was the most beautiful sound ever to fill that room. Gene Kranz closed his eyes. He took off the white vest, folded it carefully, and dropped into his chair. He had been standing for nearly 87 hours. "Welcome home, boys," he whispered. In the Pacific, Odyssey's parachutes opened in unison, their orange canopies blooming under the morning light. The module fell gently onto the waves, surrounded by foam. At that instant, the most successful failure in NASA's history came to an end. Apollo 13 never touched the moon's surface. Its flag never unfurled over the gray dust of Mare Imbrium, nor did its astronauts leave footprints in the history of exploration as conquerors. But what that mission did achieve was something greater than any landing, to show how far human intelligence can go when nothing is left but the will to survive. When the Odyssey was recovered from the Pacific, the images of the three men stepping out of the rescue helicopter went around the world. Lovell, Hayes, and Swigert did not look like heroes. They looked exhausted, their clothes clinging to their bodies and their gazes empty. But they had brought back more than their lives, proof that reason, calm, and cooperation could defeat even the void. The newspapers of the era called it the most successful failure in history. For a nation accustomed to celebrating technological victories, the story of Apollo 13 was different. It had not been a display of power, but of vulnerability. A mission that did not conquer a new world, yet reaffirmed faith in humanity. Gene Kranz, in an interview years later, said that week forever changed the way NASA viewed its missions. We learned that perfection doesn't save lives. The people who refuse to give up do. And he was right. NASA was not rescued by its computers or by its protocols, but by men who, faced with the impossible, decided to think differently. Lovell summed it up better than anyone. We never reached the moon, but we made it home. Aquarius, the small lunar module that had kept 3 men alive for 4 days, separated from the Odyssey before re-entry. It entered the atmosphere shortly afterward, disintegrating in an orange flash over the Pacific. Nothing remained of it. No remnants, no parts, no traces. Only its name, recorded in flight logs and in the classrooms where aerospace engineering is taught. Decades later, NASA instructors would still show the story of Apollo 13 to their students, not as an example of success, but of ingenuity, of humanity. Because what was taught was not the technology, but the mindset, that no mission is lost while someone keeps thinking. The story of Apollo 13 was not that of a catastrophe averted by miracle, but of a series of human decisions taken at the edge of knowledge, of men who chose to act calmly when panic was the easiest option, of engineers who built a solution with duct tape, plastic, and faith in logic. In museums and archives, Apollo 13 continues to remind us of a simple eternal truth. Space does not forgive. It gives no second chances. And yet, that time, humans made them. In space, there were no miracles, only human decisions and a roll of duct tape.